Hello everybody, this is Rob Swatsky from the York campus of Hack, and welcome back to my Biology 121 Anatomy and Physiology 1 course. This is podcast 2.1, Introduction to Chemistry, the Organization of Matter. It's important for any student of the life sciences to have a firm understanding of chemistry. Why? Why chemistry? Isn't this a biology class? Remember the levels of organization we reviewed in podcast 1.2. The lowest level of structural organization is based on chemistry and consists of atoms and molecules. Atoms are bonded together into larger molecules such as sugars and proteins, which act as the foundation for the structure and function of cells, the smallest unit of life. As we dig deeper into the nuts and bolts of how life actually works, the physiology of the human body, we will focus more and more on chemistry. For example, we'll learn the incredible diversity of roles that ions, atoms having one or more positive or negative charges, play in the function of cellular processes, and how cell membranes, which consist of proteins, sugars, and lipids, work to transport ions into and out of cells. Chemistry is the scientific study of the structure and interactions of matter. Matter is found in all living and non-living things and is defined as anything that occupies space and contains mass. Mass is the amount of matter an object contains, and it exists in three states: solid, liquid, and gas. Solids have a definite shape and volume. Liquids have a definite volume, but take the shape of whatever container they are found in. Gases, like oxygen and nitrogen gas, do not have a definite shape or volume. Regardless of the form of matter, all matter is built from chemical elements, and each element is made up of atoms. Think of atoms as the essential building blocks of matter, like the bricks that make up a wall. An element is a chemical substance that cannot be broken down into a simpler substance using ordinary chemical means. There are currently 118 chemical elements recognized by scientists, with 92 of them naturally occurring on Earth. Fortunately for us biologists, only 26 of these elements normally occur in the human body and are the focus of our study in anatomy and physiology. Most elements have a one- or two-letter chemical symbol, with the first letter always capitalized and the second letter always lowercase. Symbols are often abbreviated forms of the element's English, Latin, or Greek name. For example, the chemical symbol of the element carbon is C, but the symbol for the element sodium is Na, which comes from the Latin word natrium, which means soda. Only 4 of these elements make up approximately 96% of the body's mass, and these are called the major elements. These 4 most abundant elements are oxygen, having the chemical symbol O, which makes up 65% of the body's mass. Carbon, having the chemical symbol C, which makes up 18.5% of the body's mass. Hydrogen, having the chemical symbol H, which makes up 9.5% of the body's mass. And nitrogen, having the chemical symbol N, which makes up 3.2% of the body's mass. There are 8 other elements called the lesser elements, which collectively make up 3.6% of the body's mass. The lesser elements are calcium, having the symbol Ca, phosphorus, P, potassium, K, sulfur, S, sodium, Na, chlorine, Cl, magnesium, Mg, and iron, Fe. There are 14 other elements called trace elements that are found in very small quantities in the human body. Even though they collectively make up about 0.4% of the body's mass, many of the trace elements play important roles in the body and are required in these tiny amounts. Think of trace elements as being similar to the ingredients we use in small amounts in cooking, such as salt, pepper, or a spice that packs some heat like red pepper flakes. Too few of these ingredients can make an otherwise tasty dish bland and flavorless, while too much of these ingredients can overpower and ruin a dish. The trace elements found in the body include aluminum, Al, boron, B, chromium, Cr, cobalt, Co, copper, Cu, fluorine, F, iodine, I, manganese, Mn, molybdenum, Mo, selenium, Se, silicon, Si, tin, Sn, vanadium, V, and zinc, Zn. If you take a daily vitamin, take a look at the ingredients listed on its packaging. You may recognize many of these important trace elements included in the vitamin. We'll be exploring the roles that the major, lesser, and trace elements play in the body's structure and function in this and future chapters. Thanks for watching, and please feel free to contact me by email at rjswatsk@hack.edu if you have any questions or comments about the course.